This is a figure of three charged particles and the distances between them. Particle A has a charge of -1 nanocoulombs, which is 2 centimeters away from charge B, which has a charge of -2 nanocoulombs. And this is 1 centimeter away from charge C, which has a charge of +2 nanocoulombs. Here I have drawn the forces that the particles will place on one another. The force of B on A, which will be upwards because they are like charges, and the force of C on A, which will be downwards because they are opposite charges. Step 1 is to find the value of the force of B on A. To do this, we use Coulomb's law, which is F equals K times charge 1 multiplied by charge 2 divided by the distance between them squared. K being the constant 9 times 10 to the 9th. Plugging in our own values, we get that the force of B on A equals K times -2.0 times 10 to the -9th coulombs multiplied by -1.0 times 10 to the -9th coulombs, all divided by 0.02 meters squared. Solving this, we get that the force of B on A equals 4.5 times 10 to the -5th newtons upwards. Step 2 is to find the force of charge C on charge A. To do this, we use Coulomb's law again, and we get that, and plugging in our own values, we get that the force of C on A equals K multiplied by 2.0 times 10 to the -9th coulombs multiplied by -1.0 times 10 to the -9th coulombs, all divided by 0.03 meters squared. Solving this, we get that the force of C on A equals -2 times 10 to the -5th newtons downwards. Step 3 is to find the net force on A using the forces we have already calculated. F net A equals the force of B on A plus the force of C on A. Plugging in our own values, we get that F net A equals 4.5 times 10 to the -5th newtons minus 2.0 times 10 to the -5th newtons, which equals 2.5 times 10 to the -5th newtons upwards.